Hello, friends. Hope you're doing great. Excited to get to spend a little more time with you. Very excited to talk about the second exam today. And so the second exam today, let's just go ahead and share my screen and get things started. Um, here's what we have in Canvas. Now, it says, use the cashier's algorithm and develop a program that randomly selects a total charge. Then randomly select a payment in dollars and cents that exceeds that charge. So we're getting some conditions for our program. Then have the program calculate the charge in pennies, nickels, dimes, quarters, ones, fives, and 20s. Bonus points for anyone who writes a program that can count change back. Now, just talking hypothetically, uh, let's imagine that we're going to go to Walmart and we're going to buy penguins of Madagascar for like $5.95, right? So after taxes, let's figure a 20% tax rate. So that'd be a fifth of $6 is going to be, I don't know, 30 cents or something like that. So we'll say it's $6.25 is our total. All right, so we lay a $20 bill down on the counter. So if our total was $6.25, we'd need 3/4 to go from 6.25 makes 7, 3/4 makes 7. And then three $1 bills would go from 7 up to 10, and then another 10 makes 20. And that's counting change back. And this is from my misspent youth where I sold hours of my life every week so that I could afford to buy pizza and parts for my rollerblades. That was a poor choice on my part, but you know what? Hey, these youth happens. All right, so what we're going to do is we're going to try to simulate this inside software and see if we can write this program. So what I wanted to do, I know that they have this part in the book, and this is called the greedy change making algorithm. They didn't actually call it the cashier's algorithm, but it says the greedy algorithm, algorithm 6, produces change using the fewest coins possible. And that is what we're excited about doing here. And it gives this nice little explanation and says, we can devise a greedy algorithm for making change for n cents by making a locally optimal choice at each step. That is, at each step, we choose the coin of the largest denomination possible to add to the pile of change without exceeding n cents. Okay, well, yeah, we'll go ahead and grab this. All right, so in here, do I have a discrete structures? I do. And let's go ahead and I'm going to make a new package, and let's call this one exam 2. I don't use the package info, so I'm not going to worry about it. All right, so I'm going to make a new class, and I'm going to call this cashier algorithm, public static void main. I'm going to make this a little different. Okay, so this thing does run. I'm going to admit I haven't done this one before, so my tutorial today may not be as crisp, but we're going to give it a shot anyway. Boom. this. I just like to do this so I can read through it just a little bit closer. I like that this is an example that we can follow. All right, so that's kind of a description of the algorithm, but I also want to have a description of this. Okay, I want to see if I can get away with something. Okay, let's see if the magic happened. Poof, there it is. So we're going to use the cat. This is just a different way of saying the same problem. Okay, so the first thing that we need to do is develop a program that randomly selects a total charge. So I'm going to say double total charge equals select total charge. All right, we'll have to do some fun stuff. We'll go ahead and create this. All right, so we're going to do int total dollars equals int. Actually, I'm not going to get that creative. I'm not. I'm just going to do double charge equals. Let's do math.random. Whoops. Times. Yeah, that should work. So let's just print this right quick. Okay, so we'll come in here. Cool. So it is generating a number that is in the range that we want it that we want to see. Okay, but this is a little weird because you can't have all these extra digits. So let me see if I can. Okay, so we're gonna Java round double. Whoop, there it is, to 2 decimal places. Stack Overflow, what do you have for me today? Oh, okay. You know what? Let's do it. It'll work, maybe. Okay. So we're going to say round, and we're going to take that. So first thing we do is we multiply it all by 100. And then we're going to divide it by 100. Okay. Cool. Now I've got something. All right. So it says develop a program that randomly selects a total charge. Total charge selected, my friends. We are moving right along. Then randomly selects a payment in dollars and cents that exceeds that charge. Cool. Let's say, I'm going to say while, let's say, when Boolean equals false, I'm going to say while not payment, and I'm going to cut this out, drop this in here. You know what? Yeah, this is going to work just fine, friends. Okay. Actually, did you find what you were looking for? Question mark. And now we're going to get down here, drop this in. Thank you for shopping with us. All right, save it, run it. Now we're stuck in an infinite loop. Let's kill that off. Okay, so I'm going to say, I'm going to do this the laziest way possible. I'm going to come in here and I'm going to say double payment. And that creates it. And then we're going to come down here and I'm going to say payment equals, and this is my level of laziness this morning. We'll just copy that. And you know what we're going to do? We're going to say if payment less than or equal to, if payment greater than total charge. We'll just drop in the curly brackets, and I'm going to say one of the things that I don't think I point out frequently enough is that my spelling is atrocious. Okay, so we'll go after this while loop. And we're going to say, all right, save it, run it. Oh, says there's problems. Says it fixed the problems. Cool. Now we have the ability to select a charge and a payment that is larger than that. And I think it's always going to work out that that's going to work. Now we could get some significant disparities, but I'm okay with that. All right. All right, so now here we go. Let's come in here and I've boxed this, right? So it's always going to be within $100. Now, if this is not necessarily going to scale great, but it does box the problem. And so now I can start working with it. I'm going to say int. 20 count equals calculate 20s, and I'm going to pass it charge, comma, payment. Okay, so what we want to do, we're going to create this, of course. All right, so we want to calculate how many 20s we can give back. So we can say, say Boolean, need more 20s equals true, while need more 20s. I'll say, I also have 20 count equals 0. Okay, so this one is just an if statement. It's going to be if and I'm going to do payment minus, okay, I'm going to come in here and I'm going to say double new payment. So we'll just say working payment, because it's not really a new one, it's our working one. This is going to get a little bit ugly, and I admit that this is going to get a little bit ugly, but yeah, I think we can make this work. Okay, so payment minus 20, working payment minus 20. If working payment minus 20 is still greater than total charge, then what we're going to say is we're going to say count plus plus. So basically we're going to say, okay, we are going to need to give a 20 back and change. And then we're going to say working payment equals working payment minus 20. So I'm gonna change this just a little bit here. I'm gonna say int current denomination equals 20. And the reason I'm going to do that is because I can see me making my life difficult later if I don't do this. Oh, you know what? You need an int. I apologize, friends. Okay. So we'll just make a little note to ourselves. Okay. Where is it not happy with me? Working payment. Double working payment equals payment. Okay, let's try this again. Oh, yes. Probably we need to say, if this is true, else, then we say, so it's nice. Need more 20s. Need more. We'll just make you need more. So we'll copy that, paste that, paste that. Okay. So I think this is going to work. Let's give it a run. That's a great example to start with. You gave me $64.50. The charge was $20. Personally, if I was a cashier, I would have just like handed you two $20 bills right back. If you handed me three 20s, four ones, and a 50-cent piece. And yeah, we're totally doing 50-cent pieces. Okay. Because I think I just figured out a way that we can kind of grease this algorithm up a little bit and make it run a little quicker. All right. So we need, I'm going to change this verbiage back. We need to back always save. I like saving. So we need to give back 120s. All right, you know what? I'm going to be okay with that. We should drop an if statement in there, but I'm going to be okay with that. So I'm gonna refactor this just a little bit. I'm gonna come in here and I'm gonna rename, refactor, rename. I'm gonna say calculate how much of to give back. Okay. So I'm going to come up here and I'm going to say int destination equals 20. And now I'm going to come in here and I'm going to drop in denomination. We're going to go ahead and we're going to add this. And I'm going to change, oops, let's wrap that just to make it prettier. There, okay, thank you. And then I'm going to delete that. Look for red squiggles. All right, save it, run it. So the charge was 21 bucks. You gave me two 20s and a 10. So I'm going to give you 120 back. Yeah, I can live with that. Okay. I'm fine with all of this, but we need, I'm going to come back here and I'm going to say int, no, I'm going to say double total change equals 0. Now, this is to help me keep track of this later. And so I'm going to copy this. I'm going to come in here and I'm going to paste it. And I admit this is starting to get silly, meaning I've got too many things that I'm passing in. This is not clean code, and I understand that. Oops. Copy this. Total change. There we go. Call that total change. Working payment equals payment minus. Actually, I think I have this saved in my clipboard. I do. Yay. Okay. So now I have denomination equals 20, and we can say this, and now we can come in here and we can say, we can update. So we'll say denomination equals 10. Total change equals 20 times count. I think I can get away with that. And then I'm going to just highlight these two rows. Actually, this is really bugging me. Cast argument total change to int. Change type of total change to int. Total change. Oh, I see. That's kind of confusing. Total charge, total change. Why is it not happy? It's supposed to be returning an int, returning a 20 count. Oh, you know what? So just recast this as a double. Is this? Method calculate how much denomination to give back is not applicable for double, double, int, double. That was my mistake. I apologize, friends. I didn't realize that when it grabbed it, it just pulled it down as an int. That was my mistake. Okay, so we can save that, and now we can come in here. We're going to grab these two. I'm going to make this the 10 count, and denomination is that. Da, 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 da. Copy. Okay. Okay, that's not wrong. Cool. So 87, we're going to give back a 20. That's going to make it 67, and a 10 will make it 57. Cool. So this, I think this just got, a little bit easier. And now I'm going to come in here and I'm going to do an array. I'm going to say int change equals new int. There's a way to do this. So Java array create with values. Yeah, that's what we need. Curly brackets. So it's like that, and then we just do curly brackets. Okay, it occurs to me though, we're going to have to change this to a double. And that should cause problems down here because denomination is going to need to be a double. Drop in thing right there. Okay, 20, 10, 5, 2, 1, and then we'll do 0.5. There's a 50-cent piece. There's 0.25, 0.10, and 0.5. 5 for the old nickel, 0.01. Okay. And now we save that. Denomination equals 20.0. Okay. So double is our denomination. That would make that make sense. Okay, so I mean, other than I can't spell. All right. Let's refactor this and let's call it denominations. And I'm going to say, I'm going to have int change equals int new int, and I'm going to do okay, cool. Now let's get silly with it. Let's come down here. I'm going to say for int nation index equals 0. Less than So now, now I've got this, and I'm going to say change of denomination index equals okay, and instead of denomination, this needs to be denominations of denomination index. Cool. All right. And then I'm going to say this, something like this. And this is getting pretty cryptic. Total change equals and this. Okay, so that should update it. I'm just going to come down here and pretend like I knew what I was doing and just kill that off with a block comment, and actually kill that off with a block comment. Okay, so the first thing I want to do is just does the stupid thing run. Cool. And I'm going to come down here. Okay. Total change equals probably total change plus. All right, so let's just look at this and see without a round off error if we're having problems here. So 60s, yeah. No, I'm not even gonna math this morning, okay? So let's just take this, pop it over here. I need to know what is 51 point, what is 40.67 plus 51.81. 92.48. $67.81. Huh, that's a lot for a round off error. Did I get a penny? My denominations? Yeah, should have. All right. That's a little bit disheartening because that was a penny off. Well, we can see 81 plus 67. 1 and 7 is going to be 8, not 9. So I wonder if I'm getting some round off error. You know what? Let's go ahead and let's grab this line. it's going to be something like this. So I'll just grab those little bits and bots right there. I'm going to paste this in here. And so we're going to need to grab this part, drop that in there, and then that part. And yeah, we're going to need to wrap this. So that much. Wrap it again. Put it in there. Save that. This served its purpose. Okay, it's still coming up a penny short. You know what? That's this part down here. If less than or equal to. Okay, and so I'm going to refactor this because that's no longer correct. Rename, and this is going to be nomination count. Okay, see if that just bricked the whole thing. See, that's funny to me, connecting. So I'll go ahead and share my screen again. Hopefully this is still a continuation of the same video. So here we are. Continuing on with the code. So 86 plus 12 is 98. I feel good about that. 5. Yeah, I'm not quite getting there with the penny. And so I'm a cent off. I understand that I probably should be a good kid and go back and go for it. And instead, I'm going to say I can live with being a penny off. I'll probably get fired at the end of the day as a cashier, or I'll figure out what I was doing wrong in my stuff here, and I'll go do that. So, but let's start counting the change back anyway. And then you know, I don't know if this is a horrible idea. This is a horrible fix. I'm just going to come in here and I'm going to say change of length -1 equals plus equals 1. It's so stupid. But it seems to be happening consistently. So I'm going to just, this is a horrible plan, but I'm going to just add a penny onto everything. Okay. All right. So you gave me, all right, so this is not helpful. Total charge was $8.40. You gave me $28.78, so I don't need this anymore. 57. Okay. That's weird. Okay. No. Oh, goodness. Oh, that was right. Okay. So you gave, the charge was plus, and this will be, okay, now we're going to do it backwards. All right. So this is going to be kludgy. Well, let's start the easy way. Plus, this will be I'll say and I'm gonna have to come in here. I'm gonna say double running total equals charge. Need this. Say home running total equals that. It's us two. Oh, you need to do a plus sign there. So I'll leave that. That. Actually, I won't. I like the concatenation out front. Gets us to, and then I'll say plus running total. I'm okay with it. So that problem goes away. That problem goes away. Okay, let's try this. 2 gets us to So let me look at this. Running total plus math.round denomination. I wonder if that's the problem that's trunking me. That the way I'm doing that is trunking me. And I'm not going to worry about it. Okay. All right. I'm going to say 4. Let's grab this. Paste it here. I'm going to switch these two. Call X 0. That way, that. Minus 1 equal to at AI, save it. Oh, I don't like that. Okay. All right. Okay. Yeah, we probably need to have this part propagating through this. Okay, denomination index. So we'll do that. Do that. We'll do that. We'll do that. See if I screwed that up anywhere. Okay, total is 296. You know what? You're not, it's not, something's not indexing right there. Running total. Equals plus. Total charge. Good. Total charge. Running total. $668. You know what? I'm going to take this little process out of here. Okay, so it doesn't, oh, it doesn't like that. That would make sense. Well, that seems to be working better. 2 cents gets me up to 24, plus nothing stays at 24. 49, yep, plus a 50-cent piece gets us to 99, plus $1 and a $2 bill. Cool. So that's it. All right. Well, I'm going to say add all my changes and say added I know that I need to do a poll first, so I'm going to do poll. So I will just commit, and now I'll do a poll. Launch configuration. Oh, cancel. It's currently running. Save it. Okay, get staging. Now can I do a poll? Because I think I've done some other pushes. Okay, so that worked. Okay, so now I'm going to come in and just delete all this stuff that I use down here for notes, just to have an excuse to make a commit. Save, save all changes. Oh, I know what I need to do. No, that should be shared. Yeah, that should. Try to push up. I hit commit and change and push. And it says push to Eclipse. Okay, so let's talk about this right quick because I kind of zoned out while I was programming a little bit. I didn't do a good job of narrating. Okay, so here's what we've got. This is kind of blah, blah, blah at the top. And then this is my code. And so here's my main. This is kind of setting the problem up. And this is how we figured out how much money that you just gave me. And it's a really ugly system, but it works, right? Now, I'm going to come in here and I'm going to come out with payment equals select payment. And I'm going to pass it total charge. And I'm going to see, actually, let's undo all of that. And this is the part where I'm talking about. Okay, so take this, cut it. Refactor. Extract method. Double. Parameters. Total charge. Okay, let's see what that looks like. Perfect. And so we can still run that. Yay, this brings me great joy. Okay, so here we go. This is the code, and it's still kind of a kludged up mess, but that's okay because I'm going to make another video. All right, so with that, you can find that up on Eclipse. It's under Discrete Structures. I'll just add it one more time. Refactor, late, payment, commit and push. Save, yes, and try it again. Oh, hey, I'm on there. Oh, wait, that's not right. Hopefully it goes clean that time. Push to Eclipse origin, cool, all done. All right, so that should be up there. That's the nitty gritty detail. I'm gonna go ahead and stop there, get this one recording and converting and see if I can make another.